Hello all, welcome to VLSI drilling channel. Please like and subscribe for more videos. So today we will be going through general RTL coding guidelines. It's very important for all those who do RTL coding or who wants to learn the RTL coding. So some of the things that we should take care during RTL coding are like this, explained in this presentation. We will go through it one by one. Sensitivity list. Sensitivity list should be completely specified for each Verilog always block. Incomplete sensitivity list can result in simulation mismatches between HDL and gate level design. Example of incomplete sensitivity list is like this. Here C is dependent on A and B both values, but we are giving only B value in the sensitivity list. So whenever there is a change in A, it will not get triggered and the value C will remain unchanged. So it's very important to mention all the elements in the sensitivity list. Value assignments. So blocking assignments, they are dependent on the ordering of the assignment, while non-blocking assignment, it is independent of the ordering of the assignment. For correct simulation results, we should use non-blocking assignments within sequential Verilog always block, and for immediate blocking assignments, for combination Verilog always block, we should use immediate blocking assignments. Never mix a description of combinational blocking construct with that of sequential non-blocking construct. Why blocking assignments in combinational Verilog always block? So because the final outputs depend on the order in which the assignments are evaluated, blocking assignments within sequential block may cause race condition. So they are not used in sequential block, they are used in combinational always block. And why non-blocking assignments are used in sequential always block? Non-blocking assignments closely resemble hardware as they are order independent. Most of the applications which require data transfer within module are required to be written using non-blocking assignment statements. If statement. In case of if statements, if they don't include else condition, the design compiler creates a latch. So we should provide all else conditions so that there is no latch inferred. For example, if A equal to 1 and B equal to 1, then Z equal to 1. Now there is no else condition. What will happen when A and B are not equal to 1? Then what will be the value of Z? Then it will create a latch. It will always assign 1 to the Z, past value to the Z. How to avoid latch from if statements? Latch inferring can be avoided by assigning values in all possible cases. Else conditions must be included in if statements. Case statements. When if statement contains more than 3 conditions, case statement can be considered to improve the parallelism of design and clarity of the code. An incomplete case statement will result into latch creation. Latch inference can be avoided by using either default clause or the full case compiler directive. The full case compiler directive asserts that all the valid input values have been specified and no default clause is necessary. The default clause specifies the output for any undefined input values. For best results, default clause must be used instead of the full case directive, because gate level simulation might not match the RTL simulation. whenever the case expression evaluates to an unspecified input value. Now comes constant definitions. Verilog tick define statement must be used to define the global constants. Global constant definitions can be kept in a separate file. Parameters must be used to define the local constants. Clock logic guidelines. So here, don't use mixed clock edges. Mixing of edge sensitive and level sensitive lists are not allowed. In case of multiple clocks in the design, it should be ensured that clock generation and reset logics are written in one module for better handling in synthesis. If a clock is used in different modules of different hierarchy, then clock names must be kept common across all the modules. This makes constraining that clock easier and also supports better handling of synthesis scripts. Other general guidelines are mentioned here. File name and module name should be same. Use of lowercase letters for ports, variables and signal names. Use of uppercase for constants, user defined types. Inference of logic should be given higher priority. That's all for today's video. Keep learning and keep growing. Thank you for watching this video. Don't forget to subscribe this channel. We will be coming with more valuable videos for you all. Thank you. Bye bye.